In this next set of videos, I'm going to be talking to you about a small subset of something really awesome called astrobiology. Now that sounds absolutely crazy, doesn't it? Astro means sort of space, and biology, well, that's, living organisms. So you might think, well, why are we looking for living organisms in outer space? And that's precisely what we're trying to do. So a lot of people think, oh, isn't this just science fiction? Well, no, this is sort of the stuff that's science fact. In fact, a lot of the stuff that we learn about in astrobiology is, I think, way more interesting than what you see in movies. It's really, really fascinating stuff. Now, it's a large, large field, and so we're not going to be going into all the details, although I think it would be fun later on to do a set of videos and going into more detail. But for now, what we're going to be doing is focusing mainly on the physics part of it, which is detecting exoplanets. I'll give you a quick little intro about what astrobiology is and what the different fields do, and then we'll sort of focus then on the physicsy stuff. So first of all, astrobiology, what we're trying to do is we're trying to find life on other planets. So this is really what we're doing here. So we're trying to search for life on other planets. And I wouldn't really just say planets, I'd say also moons, etc. In other words, we're trying to find life somewhere else. In other words, we're trying to answer this question. Are we alone in the universe? Now, sadly, all we can say for sure so far is the jury is still out. We're still trying to detect other forms of life. So far, we've only ever detected life on Earth. But of course, absence of results doesn't mean that there's none. It just means maybe we're not looking hard enough, maybe we're not looking correctly, or maybe we really are alone in the universe. And this brings up all sorts of really interesting questions, I think. And it's very fundamental. I mean, I think if we ever detected some life in the universe, it would really change our entire understanding of our place in it. Now, astrobiology is a field that combines many other fields. I think that's why it's really interesting. Okay, so it combines many different disciplines. So this is what I think is really interesting about it, is that some people are astrobiologists, they do different parts of it. So astrobiology is a really neat field. You can, for example, look up, NASA has a really good astrobiology webpage. But there are lots of universities that are starting to consider astrobiology as something really interesting. And the reason why it's interesting is because, well, this search for life on other planets, you require a lot of different sort of backgrounds. So for example, there's lots of other backgrounds, but you need geologists. Because what they do is they look at rocks. And what do they look within the rocks? Well, they try to find evidence for life, question mark. So for example, on Earth, a geologist can look at the different layers of rock, the different strata, for example, and take a look and see, oh, look, there's a fossil. And they can tell all sorts of things about the age of that rock. And from then we can look on Earth, for example, and say, oh, that means that we can see evidence that life started roughly, these many billion years ago on Earth. And look, there was also liquid water even then. So then that tells us something, So these looking at rocks is really important. And that's what they're trying to do, for example, even on Mars. So, for example, they might ask, was there water on Mars? Well, geologists can answer this. And it turns out, by the way, it's not just geologists. A lot of the people in this field, they all learn a bit about each other because it's all interrelated. But if we sort of generalize a bit, they're mainly concerned with rocks and what evidence life may leave in rocks. And then looking at rocks from other planets or other places and trying to find evidence then of life in those ones. So the question might be, was there water on Mars? It turns out it really looks like there was. So actually, this is pretty new stuff. It turns out, yes, it looks like there was liquid water on Mars. In fact, there is lots of H2O on Mars. There's lots of it trapped in the poles, for example. Are there other places with water? Of course. There's places like some of the moons. So, for example, there's a place called Europa. It's one of the moons, not of our planet, of course. But you can take a look there, and there is a whole bunch of liquid water within that moon. There's another moon called Enceladus, and that one might have some. At least it's lots of ice. There's lots and lots of places just in our own solar system that are interesting to look at least. But we might wonder, well, what about places not only in our solar system, but outside of our solar system? So all of this is related to astrobiology. Here is, for example, a picture that was taken from the Phoenix lander. This is on Mars. And on one certain day, they dug a little trench and they can see some sort of ice here. So that shows that there was some sort of, water can't really exist very easily in a liquid form on Mars through various reasons, but due to its atmospheric conditions, water doesn't really exist as a liquid on the surface. But turns out, they saw some ice here, and look at these little pellets here. And 4 days later, those things had disappeared and things had changed. So, there is definitely some sort of H2O going on Mars. So that's something really interesting. Well, chemists, I like this little joke here. If you're not part of the solution, you're part of the precipitate. But of course, then what they do, they're looking for example, what elements are present in the atmosphere, maybe on the ground, something like that. So they're basically looking at what are these elements present. They might look at, for example, what elements or what ingredients are needed for life. So they might be considering that. And of course, I'm very much doing a generalization. Chemists do a lot more than just this, but they might be looking at this, though. What ingredients are needed for life? How might the atmosphere work? So again, it's not like you just have one chemist who does one job and you just have a geologist who does one job. These people do a lot of the different jobs sort of together. But chemists are basically looking at the chemistry of life, and then, of course, comparing the chemistry of a planet or another moon and seeing if that is conducive to having life. Well, of course, we have biologists as well. Now, these biologists, they might look at, for example, maybe we want to say, how do we even define life? If we're looking for something that's alive, what do we mean by that? That's not actually such a simple question to answer. They might also look at things like, what conditions are needed in order to start life. And that's even harder to answer. Now, it turns out, for example, on Earth, everything that we see that's alive seems to be related to water somehow, to liquid water. So one of our main things, for example, is we look for liquid water on other worlds. Why? Well, because that's what we see here on Earth. Is it possible that life can exist in other conditions that don't have water? Maybe. But we don't know about it. So that's why a lot of people say, you could have, instead of carbon-based life, also maybe you can have silicon-based life. Well, maybe, but we haven't seen many examples of that, or actually none. So what we do is we use our best guesses as to what life is like on Earth, and we try to look for those similar signs. Now, of course, that doesn't necessarily mean we're right. Maybe we'll detect life some way that's not based on what we understand. But at least, we think it should be sort of carbon-based as well. Of course, that involves chemistry as well, right? And also geologists, because they look for these signs of this. So basically, we're looking at what are needed to have life. When did life start on Earth? What do you need? So, for example, on Mars, we know it had liquid water. So the question is, did it used to have life on it? And if so, how can we find it? So the biologists try to look at some of that stuff, and then the geologists try to look at the rocks on Mars, not in person, but of course with robots. Also with maybe little pieces of rocks from Mars that actually were deflected from the surface, or knocked off the surface and actually ended up here on Earth. That's actually happened. But in any case, our whole goal is to try to find out, something about life on other planets. And what is really cool is that, well, here on Earth, for example, we have all sorts of weird types of life just on our own planet. So, what might life look like on other planets? We could only guess. And now what I think is really interesting, though, is that just recently we've detected these, well, not really detected, but sort of scientists they've discovered these things they call extremophiles. These are sort of bacteria and organisms and things that can live in very extreme conditions that we didn't think would be possible. So for example, we used to think that you needed the sun in order to be sort of a source of energy. But it turns out, way at the bottom of the ocean where there's no sunlight at all reaching it, it's too deep, there is some life down there because of these hydrothermal vents. So it's crazy pressures, it's super dark, and these things are actually very, very hot near these thermal vents, and there's some organisms that can live there. And it turns out then some people have thought, oh, well, can life even live out in space? Well, we can't, not without a spacesuit. But it turns out there's bacteria and there's other organisms that can actually live out in outer space. And they've actually tested this out. They've actually slapped some bacteria on the outside of a big sort of, there's actually one thing that was called stone, they called it. So they took these big chunks of material and put bacteria on the outside, had them go in orbit around the Earth and had them re-enter to try to see if they could first of all survive being out in space and also survive the hot re-entry. And it turns out, yes, some of those bacteria can survive just fine. They can survive the high radiation from the sun. In fact, one of those types of bacteria, they've actually nicknamed it Conan the Bacterium instead of Conan the Barbarian. And that's because it's a type of bacterium that can live in really crazy conditions, super high radiation. So there do exist organisms that can live in extreme situations, which means it gives us even more chances, I think, to find life on other planets. Because maybe if there is the right ingredients, like what we have, maybe if there's the right conditions, then you can have life on other planets. Perhaps. Now, what I thought would be kind of fun, I did this actually for a presentation. I put these next 3 slides I'm going to show you here. These are things that I put together just to show, well, for astrobiology, if we're going to look for what life looks like on other planets, look at how weird some of the organisms are here on Earth. There's an anglerfish that has this little thing right here in front that sort of lures prey. And it may look really scary, but don't worry, it lives really, really deep in the ocean. It's really small. This II lemur, my wife and I, we actually visited Madagascar and we saw some of these, and they're really creepy looking, but they're really cute. They live, they basically spend most of their time in the dark, so that's why they look kind of strange. This Dumbo octopus, I think, looks really funny, for example. Giant isopod looks super creepy. And then, of course, we have other animals. There's these little nocturnal animals here in Borneo, or there's these viperfish. Again, these ones live really deep in the ocean. Or there's a yeti crab that looks really furry, or there's a thorny devil from Australia. Just showing that here on Earth we have some crazy-looking animals. Look at this chameleon. I think it looks really cool. And then we got this guy. He's all nose, and this one here is all ears. And it's like this one looks like he's missing a nose. So if we're going to look on Earth just at life, there's really a great variety. So what might it look like on other planets? We have no idea. We can only guess. And of course, other people who are involved in astrobiology are physicists. What might we do? We listen for aliens, it turns out. So there's a team of scientists who are actually listening for ET. It's actually called SETI. There's other programs too, but this is one of the more famous ones. It's a search for extraterrestrial intelligence. They've got these radio telescopes that are looking up at the sky, basically, and listening for signals from possibly aliens. We're also looking for planets around other stars. And of course, we do lots of other things, like help out with, what the atmospheres might be like and how to actually get probes to these planets and these moons and things like that. So all these people, we all work together. But physicists, this is sort of the main thing is, yes, we listen for them. We also look for planets around other stars or, of course, trying to detect where there's liquid water and things like that. So we're going to be spending the rest of our time then on this part right here. This is what we're going to focus on in the next few videos. It's going to be, how do we detect planets around other stars? That's sort of the piece that I'm going to go into a lot more detail with you. It's going to be, how do we find planets around other stars?